Hello everyone. I hope you can hear me and you can see me well. So thank you for joining today or tonight, and welcome to our online meetup. And my name is Egor, and I'm Startup Solution Architect at Amazon Web Services. And this is AWS User Group Ukraine. And thank you so much, AWS User Group Ukraine, to organizing this talk. And today we're going to be talking about Lambda and Scalable architecture. So today we're going to have two guests. One of them is my colleague, solution architect from Amazon. His name is Alexander, and he's going to be talking about Lambda and all the interesting details. Maybe you've heard, or maybe you're going to learn something new about this serverless technology. And another guest today is Daniel from a company Bizzabo. He's going to be talking about adoption and transformation of his company and the way how they build scalable architecture with Kubernetes. So again, thank you for AWS User Group Ukraine for putting this event together. I want to remind you that AWS User Group Ukraine is a peer-to-peer Ukrainian community for sharing experiences around AWS and cloud technologies. It's all you want to know, all the friends and colleagues you want to connect with and talk about AWS, about features, about like cloud, about innovation, about technology, services, insights, and answer questions you might have, or maybe find some new information which is going to be helpful on your journey as a IT professional. So for timing today, we're going to be starting with Alexander in the next few minutes, and then it's going to be Q&A. I want to remind you that we're going to have questions on a platform called Slido, and the link is going to be posted on the chat notes. So please look out and see whether you want to ask questions. Just put them there, and I'm going to be going with each of the guest speakers today and going through those questions and make sure don't forget to put them on the slide. And before again we get started, when I read the topic and when I saw the presentations of our guest speakers, Lambda and Kubernetes, that's two words together actually resonated in my heart, because I remember the startup which I was working before joining AWS in 2019, and we wanted to quickly put together a proof of concept for incoming receiving API service where we should have been integrated with one of our clients, and the only way was to create a API and receive the calls from them, and we were collecting some sort of events, and we were wondering what's the best way to go. We already utilized Kubernetes at that point, and we were wondering, should we go and do a fully blown Kubernetes implementation? It would take some time, definitely going to scale, but that was interesting that we would have to invest some time to build like the web service and just accept those API calls and make sure it's scalable, make sure that we process everything. Or we decided to go with Lambda and put together a quick POC where we can get those events quickly transform them and drop the payload into S3, and then later on we, based on event-driven architecture, would be able to process it. So we end up building actually POC on Lambda, and it worked well. And when we went to production, it scaled actually pretty well, and it was easy to use. Initially, I thought that it's just prototyping, interesting concept, but after implementation of this integration, I realized that Lambda is very interesting and powerful tool. So that's one of the topics that we're going to be covering today. And about Lambda, we're going to talk with Alexander. Alexander is a solution architect, as I said, colleague mine at AWS. His focus areas on infrastructure as a code, application modernization, and the Microsoft workloads on AWS. And he very senior technologist with 20 plus years of experience in designing and building various business applications and help AWS partners and customers in their long technical enablement and build scalable architectures at AWS. So basically, Alexander, stage is yours, and maybe you can tell us a few words about yourself before start the presentation.
Yeah, good evening, everyone. And I think you gave like a great introduction to myself, so I won't repeat it. But yeah, my name is Alexander, and I work at AWS. I'm based in Stockholm, Sweden, but originally I'm from St. Petersburg, from Russia. Live in Sweden for last 12 years, and yeah, with AWS for last 2 years, making .NET great on AWS and Microsoft workloads great on AWS. So that's my areas of expertise. And today I'm going to talk about AWS Lambda. So I will start with kind of high level overview and then like go deeper and deeper with each slide. So probably if you have some questions in the beginning, just keep them until the end, because probably they will be answered during my talk. But if not, feel free to ask them at the end and I will try to cover them. So first, what is AWS Lambda? And if we start with very high level view, and many people actually start here and they stop here, will not do it. So it starts with some kind of event. And when you write your Lambda function code, and we have number of supported runtimes, supported languages such as Python, JavaScript, Java, C#, Go, but also you can bring your own languages using custom runtimes. And less than a year ago, we introduced support for container images, so you can package your Lambda functions using container images. And on the other side, you have different AWS services which you can interact from within your Lambda function, different databases, services, or anything you want, basically. So if we go next, look at the pricing view. So there are simply two main pricing components. So one is number of requests served by the Lambda function, and the second component is duration. And the duration is metered in gigabyte seconds in 1 millisecond increment. And again, this 1 millisecond increment, it's something which we introduced less than a year ago. So what this gigabyte second means, it means that, for example, if you have Lambda function with 2 gigabytes of memory, which runs for 100 milliseconds, it will cost you the same as if you have a function which has 1 gigabyte of memory, which runs twice longer, 200 milliseconds. And talking about this 1 millisecond duration, the important thing here that it's before that, it was measured by 100 milliseconds. So duration was rounded to the nearest 100 milliseconds. But now it's 1 millisecond, and it's good for use cases where latency is really important. So if you have functions which takes like few milliseconds, then you will benefit from it. But if you have functions which are running, I don't know, several seconds or even several minutes, and you will not benefit from this. Okay, so if we go even deeper from customer perspective, so Lambda actually it's pretty complex service. So there is a lot of options and configuration that you can alter. So here is your function code, and there is a different ways to package it, and I will talk about it later. But also there is an execution role, so what Lambda can do, what services with Lambda can access. When we have Lambda permissions or IAM, so who can call this Lambda function. Then functions can have different versions, and functions can have different aliases, and then you can do blue-green deployments, canary deployments with Lambda. So there is a lot of moving pieces which you can configure. But if we zoom in into the code part, there are two packaging mechanisms for Lambda. So historical one is using zip files. So most customers, they just provide function code, and then it's running on top of Amazon Linux or Amazon Linux 2. And optionally, you can have Lambda layers. And nowadays, we also have container images as a packaging mechanisms, which we introduced less than a year ago, and I will go a bit deeper into what's the difference. And also here, I want to mention one important thing, that container images is a packaging mechanism for Lambda function. So Lambda does not run containers. So container image is a packaging mechanism. It's quite important to note here. Okay, so now let's dive even deeper under the hood. So on the left, it's a kind of invocation path. And on the right, we have workers. And actually, workers, these are just EC2 instances, which are running a number of micro VMs and different execution environments. They are isolated using micro VMs. And we will talk about all these pieces in the next slides. So first about Lambda invocation modes. So there are 3 invocation modes which Lambda support. So you can call Lambda functions synchronously, you can call synchronously, and you can use event source mapping. And all these 3 invocation modes, they work in a slightly different way, and I will show the differences. And this front end, I mean, I called it front end, but basically this is the API which Lambda has, and then different invocation modes interact with Lambda. Okay, so synchronous invocation mode, it's used when you need direct response from a function. So function is executed immediately, and a good example here could be API gateway. So you have your API and you want to receive response as long as function executed. So asynchronous is when you don't expect response from a function, you just receive acknowledge, okay, I received your request, that's it. And a good example of asynchronous invocation could be SNS notification. And the last invocation mode is event source mapping. So it's integration with different event sources. So it could be DynamoDB, it could be Kinesis, and it's actually synchronous under the hood. And I will talk about it when we talk about event source mapping. So first, synchronous invocation mode, and this is usually the one you start with. So again, we go from left to right. So there is an event, then there is a Lambda API, and then it calls the Lambda function code in execution environment. And you use this synchronous invocation mode when you need immediate response from a function. And also you need, because you are waiting for a response from a function, errors are also returned to the caller. And also when you hit your Lambda quite heavily, then you will be throttled when you hit the concurrency limit. So it's synchronous, there is no intermediate buffer, so you will get throttle errors. So with asynchronous invocation, when you call a function, you only get acknowledgement that, okay, we received your call, we will proceed it. And then there is an internal queue which can persist with requests for up to 6 hours. And also, if there is a kind of error in execution of your function, then it will be retried. And you can use Lambda destinations or dead letter queue to put the messages which were not able to proceed. And also, like asynchronous functions, the benefit here is in terms of scaling, because this internal queue, it acts as a buffer. So you will not hit this concurrency limits, and you will not get throttled because your calls will be buffered. And the last way to invoke functions and using event source mapping. So how it works? So event source mapping is a kind of component that pulls messages from different sources, and the sources could be, I don't know, DynamoDB, Kinesis, and based on, the implementation is based on this event source. So like in Kinesis, it will be one. In DynamoDB, it will be a bit different, but you can do batching here, where you can do error handling, but the capabilities will be differ by the event source that you use. So in a short summary, like this is the quick overview with some examples on synchronous, asynchronous, and event source mapping. So synchronous, I don't know, the good example here would be API gateway, where you just wait for response from your Lambda function. Asynchronous good example could be SNS, when you just send notification using to Lambda, and you don't need any response if happen this notification. And then event source mapping, so it could be a simple queue service, so DynamoDB or Kinesis or Amazon MQ, for example. Okay, so now let's go even deeper into the Lambda execution environment. So this is right part of this diagram. So execution environment is where your code actually runs, and there is only one execution environment proceeds one request at a time. And when we talk about execution environments, we always also talk about concurrency. So concurrency, it's a number of execution environments which are serving traffic for a given period of time. And we will talk about concurrency control in a few minutes. So this is execution environment lifecycle. So if you go from left to right, so if we start with initialization, or also it's called cold start. So this is where your code is downloaded, your execution environment is allocated, runtime is started, your own initialization code is run, and then the function becomes warm. So this is where the code is executed. And then in the same execution environment, you can have a number of invocations of function. And you can have another execution environment, and again, you get this initialization and then number of invocations of a function. But again, like one environment has executing one function at a time. So now, like how this runtime architecture looks like and what are the components inside this execution environment. So first, you have various software components for your operating system. So it will be your operating system and operating system packages. Then you will have your language runtime, such as Python or Node or Java. Then you have your code which you wrote for initialization and for actual Lambda handler. And then there is something called runtime interface client. So what it does, it interacts with runtime API to retrieve events from a Lambda service. So runtime interface client, it asks for next event from runtime API, and it proceeds with event. and once it receives this event, it invokes the appropriate runtime interface client, invokes the initialization code for the function and the actual function handler. So when you package your Lambda function as a zip file, and this was the only approach until end of last year, you only provide this initialization and handler code, and everything else is provided by AWS. But we introduced this container image support, so we provide base images for all supported language runtimes. So still you can use the container image which is provided by us. You will deploy it, but you will only provide your code on top of this container image. But also we open sourced Lambda runtime interface clients for all of our supported language runtimes. So actually you can provide your own Linux-based operating system with language runtime, with your own code, but just use the runtime interface client library on top of your image to interact with runtime API. Or ultimately, if you really need to do it, I mean, you can implement your own runtime interface client, which talks to runtime API. So, and you deploy the whole container image with all the components from operating system to Lambda initialization code and handler code. But what I want to mention here is that if you provide only function code, then you are responsible for function code, and AWS will be responsible for patching of operating system, updating to the latest language runtime, etc. But if you provide your container image based on our base image or based on your image, then it's your responsibility to patch this operating system with latest runtime and latest operating system components. So it becomes your responsibility. So you need to do it. So this is a timing diagram which shows how different components interact. So after Lambda calls runtime API with some event, then runtime API calls runtime to do the initialization. Once the installation is done, runtime calls runtime API to get the event. It gets the event, it runs the function handler with specific event, returns response to the caller, and then asks for next event. And in case if there is no next event for this runtime, it becomes like frozen. So it doesn't consume like CPU cycles, you are not built for it. And then once there is a next event, it like defreezes, runs the handler, returns response, and the story continues. So, and the last thing about execution, which I want to talk about execution environment, is its size. So in Lambda, you have like only one control of execution environment, its amount of memory. And you can configure it from 128 megabytes to 10 gigabytes. But one thing to mention here that the more memory you have, the more CPU resources you have. So this 128 megabyte function will have like one vCPU, but the biggest function will have 6 vCPUs. So the more memory you allocate, the more vCPUs you have. And then for each kind of function, there is like a sweet spot when you like pay less for based on the size and duration of your function. And there is a tool you can use to try to find this sweet spot. And also, because the bigger the function you have, the more vCPUs you have, please consider using multi-threading. So assume that you have more than one vCPU and write your code to utilize multi-threading to get the benefit of having multiple vCPUs. Okay, now that's it on execution environments. So now let's talk about scaling and things you need to keep in mind when scaling of Lambda function happens. So first, a bit about terminology, not to mess up like concurrency, duration, and throughput. So there is a concurrency. So concurrency is a number of execution environments which serves functions at the same time. And the throughput, it's number of requests per second. So if your function is takes 1/10 of a second to execute, and you have 100 concurrency, then this means that you can your throughput is 1,000 requests per second. Okay, so some quotas which you need to keep in mind. So concurrency. So it's a concurrency for given region across all your function, and this quota can be increased actually. So by default it's 1,000, but it can be increased to tens of thousands if you create support ticket. And then there is a burst concurrency. So it's a maximum increase in concurrency for initial burst of traffic. So this is where we're talking about spiky workloads, like I know how to scale from 0 to 5,000. And it depends on the region. So this burst concurrency is 3,000 in the biggest regions in Oregon, North Virginia, and Ireland, when it's 1,000 in Tokyo, Frankfurt, and Ohio, and 500 in all other regions. And once you reach this limit, then the functions will scale by 500 concurrency per minute. And it's better to show it on a graph. So imagine you have this. So this is x-axis is when y-axis is a number of execution environments. So your function and the number of execution environments is scaled until the burst limit. So for example, 3,000 in Ireland, but our concurrency limit is 5,000. So here you see that we scale 500 per minute. So we're adding 500 per minute, 500 per minute until we reach the concurrency limit. And the striped region here is where you can have throttle exceptions. So if you need more functions, if you want to run more functions, you need more execution environments. We will not be able to scale faster than this 500 per minute. So you will be throttled here. And in order to control it, again, we introduced a feature called provisioned concurrency. So you can pre-warm execution environments to first to reduce cold starts, because the initialization will already be done, and then your function it will not be throttled until it reaches this provision concurrency. So again, this is how many so this is your function, how it's executed, how many execution environments it needs. So first we initially burst until the burst limit, and then we scale up until the provision concurrency, but you will not be throttled here. And also you pay for this provision concurrency for gigabytes per second, and execution for under this provision concurrency limit is cheaper than on demand. So if you heavily utilize provision concurrency, like in summary, you can save some money. Okay, so next control is reserved concurrency. So you can allocate maximum concurrency for a given function, so that this function will not be throttled, for example. So and it will so when you reserve concurrency for specific function, no other function can use that concurrency. So for example, you want your authentication API like to be not to be throttled, and so yeah, you can use this reserved concurrency feature, and there is no charge for reserved concurrency configuration. Okay, so next, what I want to show. Sorry, I see some other screen. Okay, so some other features I want to quickly mention when we talk about Lambda. So first, it's что у меня произошло? Просто я какой-то чужой. Да, так. Okay, now I need to switch to English. So other features which I want to mention. First, it's mount EFS file system to your Lambda function, and it will be visible just as a local directory. So this means that you can share data in between functions or other resources like EC2 instances. They can access it at the same time. Then you can use the feature called code signing, so you can be sure that only code signed with specific key can run. So Lambda will check every code deployment and verify that the code package trusted. And the last feature I want to mention is Rds Proxy. So if your function is talking to a database, then you can throttle actually database connections. So Rds Proxy is a pool of database connections to be able to reach high concurrency without throttling database. And the last feature which I want to mention is, I don't know if you heard about our Graviton 2 processors, but this is our ARM-based CPUs, which are developed by AWS, and you get better performance at lower cost, but it's ARM-based architecture. And for Lambda, it was, I think, like 2 weeks ago, we introduced support of Lambda functions which can run on AWS Graviton 2 processors. So when you create your Lambda function, you just specify that, okay, instead of x86 architecture, I want to use ARM architecture, and that's always needed from your side. So if you can use it, just use this feature because you will pay up to 35% less, or like your price performance will be up to 35% better. Okay, some quotas which I already mentioned, but I want to emphasize them again. So concurrent executions. So by default, it's 1,000, but it can be increased to tens of thousands. Burst capacity limit, which I mentioned, it's a hard limit based on the region. For the payloads, again, with a hard limits, so 6 megabytes for synchronous functions and 256 kilobytes for asynchronous. For deployment package size, and this is where you can benefit from container images. So when you use the zip files, before we introduced support for container images, you had to be quite smart about how you do it, how you package your functions not to exceed this limit. But with container images, it's up to 10 gigabytes, so you can store artifacts which are required for this function inside container image. Then there is a temporary storage which your function can use, and also number of invocations per second. It's limited, so 10 times of concurrent execution quota for synchronous functions and nearly unlimited for asynchronous functions, again, because we have this buffer. And some best practices. which I want to mention and finish my talk, so you come with this knowledge. So first, error handling, as you all know, it's very important. And for synchronous functions, it's up to you how to handle the errors, because function just returns an error to the caller. But with asynchronous functions, you need to configure destination on a function to store the failures so you can analyze them. So for example, for simple queue service, you can use dead letter queue, and for other event source mappings, there is a way for you to configure destination to store the failures. And the last is about cold starts, like how you can optimize it. So there are two parts in a cold start. So there is a full cold start when your function code or your container image is downloaded, when new execution environment is created, and this is where we do optimization. But then it's your code with your initialization and your handler code, and this is where you do the optimization. And cold starts, they happen quite often in development, because you don't have like that many functions running concurrently. But in production, it's quite small percent of the traffic. But still, it happens when you update the code, when the function is scaled, when new execution environment is created, when rebalancing happens, when something fails. And you can improve cold start. So you can reduce package size by creating single purpose Lambda function. So don't create generic packages with multiple functions, create single purpose functions. Optimize like what you import, do lazy loading instead of doing all initialization at once. Optimize the code. If you want to reduce the likelihood of hitting cold Lambda functions, you can use provisioned concurrency, and also take advantage of that you can reuse execution environment by doing initialization outside of function handler. So for example, in C#, if you use static variables, this data will be stored like in between executions. So keep it in mind. Okay, so that's all which I wanted to cover in this half an hour about Lambda functions. So I hope now you have some kind of more structured knowledge on how it works under the hood, what are the different execution modes, how execution environment looks like. So if there are any questions, I will be happy to answer.
Can you hear me? Oh yeah.
Yes.
So thank you so much, Alexander, for this presentation and for giving this basically dive into the Lambdas and world of the serverless. And I remember when I first had experience with Lambda more than 3 years ago, it was like really, really, really basic. It didn't have all these advanced features which we have right now. But I should still remind everyone that doing serverless and going serverless require some particular mindset, and this is a much more granular environment, and it requires definitely more responsibility of the developers. For example, from my perspective, I remember that when we created first POC, as I mentioned in the very beginning, we thought that execution of our Lambda were hitting like 2.5 seconds. So, and since you're paying for this time plus resources, we decided to optimize it. And after few rounds, we reduced execution for less than a second, and that was amazing because we optimized in 2.5 times, meaning that we immediately got this benefit of the saving resources, saving money basically on execution. So, and yes, and getting back to the question, can we? The first question is which infrastructure of the code approach would you prefer for your next project, serverless or Terraform? So would love to hear your thoughts before I
Oh,
share mine.
okay, so actually, I am a big fan of CDK. So this is Cloud Development Kit. And so this is where so in Terraform, you define your infrastructure in domain-specific language. So again, it's something that you need to learn or to master it. But with CDK, you can define your infrastructure using ordinary programming languages such as C#, Java, TypeScript, JavaScript, Python. So you just write your code, and under the hood, CDK will generate CloudFormation template for you and use CloudFormation engine to provision the infrastructure. But the code will be very easy to read, easy to understand, because we provide same default values, so you can start very easily with different services, and then if you need to tune them, you will add like more parameters, configure it further down the way. But I'm like big CDK fan, so if you haven't tried it yet, I encourage you to give it a try, because it's a great way to work with infrastructure.
Right, right. I don't want to start holy war here because it's been a lot of conversations and comparison between CloudFormation, Terraform, and CDK. And CDK is definitely advanced and loved by a lot of members in the community. But both serverless and Terraform, they are open source, and they actually supported by community. So meaning that they are kind of like viable, and they created with a community for community, I would say. I read a couple of articles which I highly recommend you to search on the internet, where engineers were seasoned evangelists advocate for using combination of Terraform plus serverless approach. And this is possible and depends on the size of your project. But again, CDK is a very good at scale and very good when you infrastructure is complex and multi-layer and have a lot of nuances and details. But if you just starting, if you're a startup or your project is small, you can consider using combination of the tools, or just a smaller serverless directly, because it's been developed for serverless application. So that's from my perspective. Let's switch to another question. Is it possible to configure Lambda to fast run after the while idle time without having to ping it once in a few? And I believe you already answered this question in your presentation. It's about the provision concurrency, and you also gave a
Yes.
few other notes on the reducing the code, simplifying, and just remember that provision concurrency was introduced recently. Again, when I started working with Lambda, that there were no provision concurrency. Maybe you want to add anything from your end in addition to that?
No, I think that's correct. I covered it. So first, you can optimize your function to reduce the cold start, which you are responsible for. So like the initialization time and uh, so everything that you do in initialization phase, it's your responsibility. So I mentioned different techniques how you
Yes.
can reduce this time.
Take
But from
responsibility.
yes, so shared responsibility, yes. But from our responsibility. So if you do not want to hit with cold starts, then you can pre-warm these environments using provision concurrency, and it can be done like automatically based on patterns, or you can do it on schedule. So there is a way how you can pre-warm these environments if you know the patterns.
Got it. Got it. So another interesting question is about limits. So is there any possibility to extend 500 megabyte temporary storage limit?
Uh, no, but what you can do, you can use EFS, for example, for your temporary storage. So EFS, I mean, you can have any size. You just mount it and use it as a temporary storage. Create some data in EFS based on function ID or whatever.
Right, right. This is one of the mindset which we need to remember when we're working with serverless and with Lambda, that there are some limitations, and you need to share this responsibility with developers, and understand that this is not just a regular web server with a just where you put all your code and it works. You need to look more granular to Lambdas, and EFS is one of the features which were long expected, where you can actually connect and either get information from EFS or drop your information on EFS and use it as a temporary storage. So consider that this is a very convenient way to do that. What about Lambda layers for sharing code between Lambdas?
Yeah, so you can use Lambda layers, but it's only if you package your function as a zip. So you cannot use Lambda layers with container image, because in container image you have everything basically. But you can use Lambda layers in functions to share some common pieces of code, like logging, for example, or some performance metering if you need. So it's a way to do this code sharing.
Right, right. Totally agree with you. Another question is what the actual benefits of running Lambda on Graviton 2? Is there anything that needs to be adopted in order to switch Lambda to ARM processors? Very good question.
So yeah, and our best answer is it depends. So if you just use your use our runtime, so you don't use very specific like third-party libraries, then probably it will just work out of a box. But I don't know, test it for your payloads, do proof of concept, so and check if it works. I guess this is the best suggestion, because if it works, I mean, you will get up to 35% price performance benefit. Just
Right, right. And with Lambda, it's all about performance, right? So you're paying for actually time and resources you spending while your code is running. And the ARM architecture gives you optimal and even more performant environment. And again, for if you're using like simple Lambdas, where you can just drop your code and you using our standard wrapper, in this case, you almost don't need to do anything because it's already taken care of. If you're using images, then you need to take the image based on the ARM and rebuild your Lambda image to take advantage of it. This is basically like switching between architectures. So it shouldn't be any challenges with that. So is there any way to easy cache responses from Lambda by seeing some headers? That's another question.
But I think it should not be like responsibility of Lambda. It should be responsibility of API gateway, for example, to cache the responses from underlying Lambda functions, I would say.
So recently, actually, we introduced Lambda at Edge. It's a similar concept of Lambda, but it's like with a smaller resources, and it's like for real this pre-processing of the headers. So you can look at the Lambda at Edge functionality, and this Lambda at Edge is actually suitable, a very good use case when you inspecting headers, and you can easily redirect or just process or pre-process your request. So look at the Lambda at Edge functionality.
Yeah, but Lambda at Edge, I mean, I want to mention that it's different from the Lambda functions which I'm talking about. So it shares the same name, Lambda, but it's different execution environments, different limits. So, I mean, nearly everything which I mentioned will be quite different on Lambda at Edge because it has to be like super fast. It's different runtimes,
Right.
but for this use case, as Egor said, check
Yes.
Lambda at Edge. But it has its own limitation. It's applicable in different use cases.
There is another. We have a lot of questions, and I'm keep going through them. And one of the interesting questions is, which workloads are not suitable for Lambda?
So again, take a look at Lambda limitations. So for example, Lambda has a 15-minute execution time. So if you have some heavy calculations which can take more than 15 minutes, then again, Lambda is not suitable for this kind of workload. Or if you need more than 6 vCPUs or more than 10 gigabytes of memory. So again, if you need some huge compute environment, again, Lambda is not good use case. But I would say the approach should be, okay, like how can I adopt my workload that Lambda is suitable for it? Because with serverless, I mean, your area of responsibility is much smaller compared to other use cases when you, I know, build your solution on EC2 or whatever. So just try to see if you can adopt your architecture to use Lambda because you will benefit a lot from it.
Got it. Got it. I totally agree with you. Look at the limitations and look at what are you trying to achieve, right? So one of the things which you mentioned, but I want to tell a little bit more about is event-driven architectures. So Lambda is very good at event-driven architectures, and it easily integrates throughout other services where you can, for example, without standing up a like web server, for example, you can put event-driven architecture where you, for example, drop in file on S3, Lambda listens to it, just picks up processing file, drops it in the queue, or drops a message in the queue. It's picked up by another Lambda in the queue, and you also use step functions if you have a more complex workflows for event-driven architectures, and that's where Lambda actually playing a great role and a like very nice Lego block which could actually easily be integrated into other services and other pieces of the workflow you're trying to build. So this is one of the great use cases. For other use cases, it's not possible to go through all of them, right? But keep in mind the nature of the serverless and of the Lambda execution. There is another question, Alexander, for you. Do Lambdas somehow share database connections or shards, or is just connecting per each Lambda instance?
And I think this is what I mentioned with Rds proxies. So, but Rds proxy, it's a feature of a database. So I think it's available in Aurora, it's available in RDS MySQL and PostgreSQL. So if you are talking to database at AWS which supports RDS proxy, then Lambda can utilize it, and then you will have like pool of connections instead of each Lambda having its own connection. So you will not be throttled on database connections when you use RDS proxy.
Got it. Got it. All right. So there is another good question: how to deal with Lambda CI/CD for updates of function code, layers plus environment vars, and while managing infrastructure with Terraform. So basically, maybe in general, managing CI/CD pipeline and Lambda updates and layers and everything. Maybe if you can give a few words about it.
So I'm not expert in Terraform, but I will talk from Lambda perspective. So Lambda functions, they have versions. So when you deploy a new version of a function, you can gradually shift traffic to this version using aliases. So this is how you can test your function and test that it behaves in production as expected. And using our code build service. So if you build a CI/CD pipeline using our code services like code commit, code build, code deploy, code pipeline. So code deploy, it supports deployment of code to Lambda functions, and it supports this blue-green deployments or canary deployment patterns. So you can configure it in code deploy based on your needs. So take a look
Yeah,
at
you
code
can
deploy.
code deploy, code star services, which suitable for serverless as well. There is another good question, and question about around security. Is there any best practices around roles and the permissions for the serverless application?
It's the same rule which applies to all other services, is to use least privilege. So when you assign execution role to your Lambda function, again, give the only required rights to this function. So if function needs to read data from S3, create a role which allows it to only to read from S3. So that's why I mentioned that you need to create single purpose Lambda functions, because when you create, multiple Lambda functions in the same bundle, then like the role that you need to assign should be the one which covers like all of them. But if you create like single purpose functions, then you can also assign these granular permissions using this least privilege principle. So there's nothing new in Lambda.
Right. Actually, this security is a job number one for us. Job number zero. It's all the services at the AWS. They're following the same concept of the least privilege, and they all of them could be fine-tuned in using our identity access management console and using policies and roles, and that's where just having those basics. If you are not very familiar with a permission model, just go and just learn it, because it is going to be across all the services. It's so important. So it should be, I believe, the one like very important like first course, which should be done for all the people who start working with AWS Cloud, because security it's super important. With a number of such a variety of incidents across the world and different situations, it's better to be on top of the edge with that. So, and the last question, it relates to CI/CD pipeline for serverless, is whether images, whether Lambda images, which is limited to 10 gigabytes, where are they stored for CI/CD? And the answer is simple. We can store them in Elastic Container Registry in ECR for further reuse and like easy management and maybe sharing between accounts.
Yeah, exactly.
All right, so I believe that's it. Thank you, Alexander, so much for this journey to Lambda, and thank you for your answers. Thank you for the presentation. It was super helpful. Again, considering that so many new updates have been introduced to AWS Lambda, and this became not just a like little POC service, but it became like really solid foundation for many experiments and many different innovations. This is important to look deeper, and thank you so much for this presentation.
Yes, and thank you for inviting me. So I hope it was useful even for experienced developers.
Right, thank you. And for everyone, sorry we had so many questions. If I haven't touched your question, we're going to be still in touch. Please look out for follow-up email after this event. And on this event, you will be able to find contacts of the AWS User Group Ukraine, where you can actually join the community and ask questions, and ask the organizers to forward the questions to us if you won't be able to find the answers to your questions. And also, it's going to be some materials based on the presentations we had today. And with that said, I want to switch gears a little bit and talk about our next guest. Our next guest is Daniel. He's a system architect at Bizzabo, and he's based in Tel Aviv, Israel. And he's working with an incredibly talented team of developers to change how the professional events are created and experienced. And he's a huge believer that software development is mostly human interaction, is that collaboration is the key of building great applications. So Daniel will talk about how Bizzabo leverages AWS and Kubernetes at scale. And I'm looking forward to welcoming Daniel. And stage is yours, please. Give us a quick few words of the introduction.
Hello, everyone, and welcome. Amazing pleasure to be here. I'm super humbled. I just wanted to thank Alexander for his inspiring presentations about Lambdas. It's always inspiring to hear from the masters themselves. So really, thank you. There's a lot in common, I think, between our and a lot of topics that came up that we're going to reiterate on, like Rds Proxy and Lambda at Edge and Graviton. But anyway, so thank you so much for joining today. I know it's getting late, but I think I have something really exciting for you today. So thank you for sticking with us. So in our agenda today, I'll start by introducing Bizzabo to you all, which this might be the best part of the session, I think, because Bizzabo is a truly amazing place and filled with amazing people, and we're building an amazing product. We'll move to a story about how our cloud architecture has progressed and its progression from adolescence to maturity, which is, I think, really a really amazing story. But before that, I think I'll introduce myself. So hi, everyone. My name is Daniel Doppelt. I'm 37 years old. I live in Israel. I'm Bizzabo's system architect. I've been working in engineering for almost 10 years now, which seems like a long time. But what's amazing about it is that I feel like I learn something new almost every day. So I started my career as a DevOps engineer a long time ago in an Israeli ad tech company, a company that was focused on serving commercials, banners, and pop-ups based on real-time bidding, all the good stuff that we like in the internet. It was a prominent industry in Israel in the beginning of the previous decade, so I hope you don't hold it against me. But I really quickly fell in love with the server-side aspect of engineering and just the way it's structured. And I ultimately got the opportunity to start writing some serious code. I feel like this opportunity really changed my life. I wrote my fair share of servers, mostly using Java and Vertex, Spring Boot. I just really always had a tendency to understand how things work from an engineering perspective. I used to be that tears apart remote controls. So I started slowly drawing myself backwards into the application perspective, the infrastructure, and ultimately really the architecture, which is what I really love to do. Being in a position where most of the actual outcome of my work relies on other people by almost 100%, really made me a believer that it's just really mostly about human interaction, working together, having fun, challenging each other, collaborating, which really is key to building great applications. But the real star of this presentation is the Bizzabo R&D, naturally. And I would love to introduce you to them as well at a much higher level, but nonetheless. So the Bizzabo R&D is around engineers strong today, which is an amazing amount considering where we have started. It's spread out across 4 locations worldwide. So we have Tel Aviv, Kiev, Stockholm, and New York City. It's an amazing bunch of people. Squads, highly functional ones, comprised of both front-end and back-end engineers working together and supported by product managers, product designers, and researchers. And using this format, our goal is really to create a highly disciplined that is enabled and empowered to express themselves and their creativity as engineers through the Bizzabo product line. So there really is no other way for us to create such high velocity and create amazing products. So that's a little bit about us. So Bizzabo, what are we all about really? So the Event Experience OS, this is where we're currently at. And it's a platform that enables event organizers and attendees to experience events like no other application offers and nobody has done before. From all aspects, it offers the best first-party tools for the job, as well as first-class citizenship for third-party vendors and developers to really create and extend the platform using components. We really believe that the industry has a lot to give as well, and it's stuck like magic. It really works. In just one sentence, Bizzabo, our mission is to unleash the power of to create impactful and rewarding experiences. I don't know how long it has been since you guys have been to like an amazing in-person event, but for me, it's been a while, and it's always exciting, and I'm always anxious. Who will I meet? What will I see? Will I learn or will I network? And you really can be anything and anyone at an event. And our goal is really to maximize, to create delightful products that people like to use, whether you're an organizer or the attendee itself. And it's a really exciting mission. So just a little bit about our background, because it's been a while. Our founders met in 2012, right after university, and they really shared a vision of corporate events that people closer together. Because it's all about the people. You go and you mingle and you mix, and they built Bizzabo. And they just keep building, iterating, pivoting, listening to the customers, trying to figure out how to make events magic. And soon Bizzabo 100 conferences a week, and really showed no sign of stopping. At that phase, Bizzabo was more of an event management software. It was really in the beginning of the company's history, but still, it was amazing. And then COVID hit. So March of 2020, just about everything stopped, and I think that in-person events may have been like the first thing to stop after flights or something. But just the drive to bring people together endured. So we designed a brand new product and paired our in-person conference tools with a new virtual event management platform, and everything started to explode. Attendees skyrocketed by like 500%, revenue doubled, more funding, and more. Just really had a new vision and a new purpose, a future of hybrid events, and that's really what drives us today. Hybrid events are coming, and we're really excited to build it, and I would love to show you throughout this presentation how it works a little bit. So there really is a fundamental change. Ever since the beginning, it's been all about the people. I think we're building a tool for organizers, but ultimately the attendee is the person who really experiences, and we just want to make it more rewarding for everybody who's involved, whether it's the team that manages the content or creates the website or the speaker who presents during virtual events or even in person. And creating a hybrid OS, it's really about redesigning the platform from the ground up, because like an application, a platform, those are two different things, and an OS is a totally new different things. It's all about the big picture, unlocking data, being extremely data driven in order to also measure the event, but to know who's next to you and who you should meet. Seeing just every chance to create communities. People like to get together, and communities within communities that would endure the event itself. And I think it's really amazing, and it's going to bring people together like never before. So let's start talking some tech stuff. So I really want to take you down a path, a really real path, the very path that Bizzabo took a while back in the day, almost 10 years ago, before containers, before like almost anything, before anybody really leveraged the cloud. I feel like we used the cloud more before microservices and terms like highly available and event-driven, resilient, chaos engineering, all the good stuff that we have today. I think you get the point. It's a really humble story, more than anything else, and I think most companies or engineers can directly relate to it. In my opinion, it's just how it started, and is my hope is that throughout this journey that we'll embark, you'll see how we've matured, but still remained humble. So let's begin. So how did we actually start? So I think like most things in life, from a necessity, right? So you're an engineer, you're a founder, you're a product team, you have some code, and you need a machine to run it on. I need something. Like I have data, I need a database to store it. They say that necessity is the mother of all invention, and I think it really showcases it. It's just something that you cannot live without. It's an immediate need, and it really served its purpose. So this is the very beginning, right? It's Genesis. It's kind of funny, right? Because it's so simple, but let's just look for a second on what we have in front of us, right? So we just have the bare minimum, right? And it's so simple. It's so naive. It's just a machine that's running a server, and a machine that's serving some client code, and it's so tiny and still amazingly significant in its value. It's like a true dissonance. It showcases the cloud in a way that amplifies its immediacy. I want something and I can buy it now. And that's like AWS changed that forever, right? For anyone. Because back in the day, you used to have it shipped to your office or data center, and I don't know. It for sure wasn't immediate, but it was very, very simple, right? So, and I don't think we can do much with this. So we basically have a web server, an API server, and a database. Now, there's more customers, there's more traffic. What do? So naturally, right, we make it bigger. So we scale vertically, and scaling vertically is just basically the easiest thing we can do at this point. I'm not sure if it really solves the problem, but the next customer can now be onboarded, right? We have a bigger machine, we can execute more compute. Let's just go have a drink, right? It's so easy. And I think after in the cloud, it just really demonstrates how strong the cloud is, because you just want more, and there is so much more to give, right? There are massive instances. But are we really going the right way? I'm not sure, to be honest, but this is just the natural progression. Now things are starting to become a little bit more interesting, right? So in this phase of the evolution, we can observe some really fundamental changes. Going stateless really opens up the possibility to distribute traffic, whether it's evenly or there's some logic behind it. Just able to control it more. And I'm in control now. Horizontal scaling saves the day here for real, right? Our monolith can scale up based on just simple HTTP metrics or more internal like CPU and RAM metrics, but it's simple and it's really good. And this is really like where we see the first springs of auto scaling and high availability. And creating this in AWS is like fantastically simple, which is amazing. I think to summarize, this diagram basically showcases a pretty simple VM-based cloud architecture that would be deployable like on all clouds today, whether it's private or public cloud, or just using virtualization. It's simple, right? It comprises of some sort of auto scaling mechanism. In this use case, in the AWS use case, these are auto scaling groups that each manage a set of VMs that have an AMI or an image behind them that execute the same processes. There are these can be layer 4, layer 7 ones and distribute traffic, and I'm able to scale vertically and horizontally. And we've separated the backend from the front end here, so we were aware that they behave differently. We're still in the monolith phase, right? This is before containers. We've added some databases for capabilities like Elastic for search and Redis for our cache to be able to serve content quicker. And I really think that this is the pinnacle of containerless deployment as it used to be. So it's multi-AZ, it's highly available, and that's it basically. It's long lasting, and I think until containers came into our lives, this was really like amazing. It used to be amazing to look at CloudWatch metrics and see everything grow. But we're Bizzabo as a rocket ship, and I don't think this is going to hurt for us. So, in all honesty, it's really getting us nowhere. I think that in retrospect, it's easy to say. After all, we're nearing the end of 2021, and really a lot has happened since. Besides COVID and besides the pandemic, a lot of so many amazing inventions and tools and open source have been created during this time. Some amazing people and amazing companies have been doing like really truly magical work during this period, and it's just really difficult to grasp how far we have come. And there's a part of me that truly wonders how startups are forming today. How do they start their cloud? Like, on one hand, I wouldn't be surprised if it was exactly the same, because these tools are tried and true, you know. But I'm really interested in hearing different origin stories, because as trivial as it is, I don't think it's going to cut it in this world. So in terms of retrospect, I know that there are many ways that we can observe the situation, but I just chose 3. So I think that using the cloud back in the day as a mechanism that will fulfill needs in an immediate way, it's just really a little bit being reactive. I think that today, using the tools and knowledge and experience that we have at Bizzabo, we are able to really understand the tools that we have better and create a vision that will really fuel growth and adhere to the business use case. I think in terms of consumption, understanding limitations of what you have in your hands would really get you further than actually just like scaling up. I think that applications that scale, you don't need to be, for instance, over provisioned, and it's just a really fine balance, and I think it's really worth investigating, and Bizzabo has definitely done that. And in terms of innovation, I have to say, for us, just the cloud, and it's any cloud. So Bizzabo is only deployed on AWS right now. It's not easy to understand that it's really, you cannot depend only on it, because there are other tools out there, and I think that in conjunction, that's the way to go. So lift off, right? There's a quote here. So Bizzabo is based on like values, and one of the values is "We Dare," which I think fits right into this slide. I'll just read it out for you guys. So it reads, "We encourage ourselves to dream big and swing for the fences. We dare to fail, but we always fail forward. The norm and embrace change. Who dares wins." I think that it's enough talking about the memory lane. Let's talk about how architecture drives the rocket that is Bizzabo. I just put a shameless SpaceX plug here because I'm a space geek myself. But we start talking about the architecture. There's just one more piece. I really want to describe the Bizzabo product line that will make up the hybrid events so that you all understand what we are building. And this really serves up the motivation for everything that's coming up, right? So really hard at work solving the hybrid event use case, an event that comprises both on-site and virtual, a natural progression from the COVID situation, right? So Bizzabo used to be on-site only. We went virtual only, and connecting those two is an amazing to solve. And some of I'll just show you the product. You know what? So the first thing that you're going to notice when you get introduced to the new product is just to focus on the people. It's just a public area where people can interact with each other and see and feel the vibe of the event, understand where things are happening, who's talking to who's consuming what content. Imagine yourself like standing in the middle of a venue, like by the coffee shop, where you can see all the rooms and you can see people like moving, and we really want to recreate this capability virtually. So Bizzabo is engineering an amazing solution for the community where each attendee here represents a dot, and those dots are alive. You are able to filter, able to aggregate them based on content and subjects, and it's powered by AI to showcase you who you should meet and who is interesting for you in the event, and what people are doing and what content you should consume. And it's just really a super high-tech solution, and the GIF is not working, but you're able to filter and the dots move and you get the picture. The next pillar is content. So you come to an event to consume content, and there's some, right, you're able to choose from multiple tracks, and there are multiple sessions, and it's all about video, right? So the agenda by itself is just like a list of sessions, right? And which each comprises of like a video stream. But it's so much more than that, because to keep an attendee engaged during a session, it's so much harder than just to make sure you have the highest video quality. Collaboration is the name of the game here. So chat, super interactive chat where you can create channels and really like a Slack-like experience. Just a toolbar where you can meet people and create video calls between each other in a hybrid way, schedule meetings with other attendees or with moderators or speakers or exhibitors. But truly where it really lies, Bizzabo is creating a top-of-the-line video solution that's really will capture the attention and the minds of everybody who is using it, whether it's the speaker or the producer or the attendee itself who is consuming the content. The next pillar itself is really moments. It's not something that's still coming up. It's Imagine like being able to take a mental screenshot of an experience that you've had in a virtual event, whether it's a cool chat conversation, meaningful, an amazing snippet of a session, something you really want to save and publish and showcase that you liked to the public, export it outside. Moments is where you're going to be able to really express yourself and be, a mini content creator during the event to others. It's really a cool feature. And ultimately, just information. Organizers and sponsors and everybody has so much information to give. It's just a static space. Do whatever you want. As an organizer, you can design it and showcase what's important to you, and grab the attention of your attendees while they register for the event or while they just learn about what's up and coming, who's talking, and what are they talking about. So that's the Bizzabo product. And I think that I'm not sure at what point we had a change of philosophy. It's a lot less reactive and a lot more planned and mature, shift left. Always question the requirements. So when we face a problem and we set required for them, like, why is it really needed? Is it really needed? Are we over-engineering it? Understanding the motivation is really where it really is. Like, why am I doing this? What problem am I really solving? I think that over-engineering is also a problem that occurs frequently, also here sometimes. Just not put it away. Throw code away. The best part is no part. Keep it lean. Automate everything. Save everyone a lot of work by automating everything. Abstractions, as engineers and architects also, we really love abstractions, right? We like everything to be organized, front and back end, just give me interfaces. And we think that abstractions without enough examples are just wrong. You end up rewriting them or omitting them or forfeiting them for something else. And I think that's one of the main things that we are focusing on today. Designing your work ahead of time, it's a really big thing at Bizzabo. I think that by designing it and collaborating before you start engineering, you're able to ultimately increase velocity and reduce the actual time to deliver. All the challenges, all the pitfalls and walls that are going to be there when your code are going to be there when you design as well. It's just a question of how you collaborate and how you deal with it. It's also easier to collaborate on a solution before you have written something because there's less sentimental value. And just in general, collaboration. Better together is another value. You can check it out at the site, bizzabo.com. I think they're really inspiring. So, yes. All right, some numbers before we start. Again, to emphasize the difference. This number represents requests per minute, just an average request per minute to the Bizzabo application during 2019 before virtual, where attendees would interact with the Bizzabo application to see who's speaking and learn about him, understand where their next session is and plan with their colleagues that have on what they're going to consume. And that's really a small number. This year, it's like a 36x36. So it's a nice number. I'm not going to compare it to anything, but I think it showcases it's just a massive growth. It really needs something else. The application was built for a different use case, and the use case has changed, and the application needs to change with it. And moreover, in terms of high availability and resiliency, there is an absolute 100% dependency on the Bizzabo platform for the event. When you're going virtual, if the video is down, the event is down. And that also is a really big motivation for engineering something good, understanding the technology you're working with, and really solving some amazing problems. All right. So I would like to introduce you to a really high level not architecture, more topology of the Bizzabo production environment. It's one thing that is obvious here that the main addition here is Kubernetes. So Bizzabo has introduced Kubernetes around 3.5 years ago. I'm not sure at what phase of Kubernetes it was, but in general, for those of you who don't know, Kubernetes is an open source system for automating deployment and scaling and management of containerized applications. So naturally, this required us to use Docker containers as well, which allowed us to package software into standardized units of deployment, development, and to ship them as one. So multiple microservices really act as one when interfacing with. And Docker containers are really the building blocks of Kubernetes pods, which are ultimately the single smallest discrete unit of compute, and are directly represented by microservices, right? And this is how it looks like when observed from really high. I'm going to bottom and showcase some front end, some back end, some databases, really try to emphasize how Kubernetes, together with the AWS cloud, gives Bizzabo at least what it's looking for. So let's focus on first. So by containerizing the services and orchestrating them with Kubernetes, we were really able to create flexible deployments on top of the cloud. We were able to engineer microservices better define data, better define service boundaries, because it's just so easy to multiply it, right? Once you have the tooling in place to manage microservices, and I'm not saying it's easy or hard, I'm just saying once you have the correct tooling for monitoring and tracing and visibility, it makes so much sense to really look at data domains in a pragmatic way and start breaking it down. And that's what Bizzabo did. So we have around 55 microservices. They're all written in Kotlin, which is a JVM language engineered by JetBrains. All services are cloud agnostic. So whenever we interface with the cloud, there's always a layer of abstraction, whether it's like a Bizzabo SDK that manages it, or like an HTTP interface, just to not create too much coupling. And by working with Kubernetes and microservices the way we do, the granularity is really, really high. So each service can behave differently and does behave differently, right? In the Bizzabo application, there are two main personas that use there's the organizer who manages it, and he is a lot more, his presence is felt before the event. He's much more focused on security. He wants a lot of data consistency. And then there's the attendees, which are, when a virtual attend, there's a session called Opening Keynote. And there are 100,000 attendees registered for the event. They will all log in 5 minutes before the session starts, browse the agenda, open the video, start collaborating with chat. Those services obviously need to behave very, very, very different. And level of granularity allows us to really tailor-make each service to its actual consumer. In a more deep dive on the back end, this is a pretty heavy slide. I think this slide showcases flexibility of the system and its true hybridness. So what we see in this slide is an application VPC, which is the virtual private cloud that all the Kubernetes clusters are deployed in, and each rectangle represents like a microservice. So microservice get their traffic from the Bizzabo load balancer, which holds api.bizzabo.com. That then gets propagated to the Kubernetes ingress controller, which is able to route traffic within deployments, stateful sets, and other Kubernetes objects based on just like layer 7 capabilities, so path or domain or headers. That's how services get their traffic. That's how we really route traffic between them. Services communicate between them over HTTP, naturally, but they also have message bus, which is not managed and provisioned by AWS. Bizzabo consumes Kafka from a third party. And then there's the databases, which are managed in their own VPC and provisioned there. They also use a hybrid methodology of managed services like RDS and Elasticache, which we'll go over in a second, as well as databases that are provisioned by Bizzabo through Kubernetes, through the operator pattern like Elasticsearch, which offers search to the services. Everything is encrypted, and I think that this is a beautiful slide, and this really showcases how you can mix and match native tools that the cloud provides and your own build tools to cater each use case. I don't think there's anything ad hoc here, but it really suits us. So it's a unified architecture. It's the same exact deployment in dev. Just in dev, we're relying 100% on Kubernetes in order to reduce cost and help spin up services quicker, because AWS instances with big that are backed by big snapshots take a very long time. So using this methodology, we are able to create the same services that behave differently in production and behave differently in dev. They have two different configurations, and using Helm, we template Kubernetes. And this results in something amazing. So in dev, as a result of a Git action, like an open PR, a developer gets a whole copy of the Bizzabo application just for himself in order to test his code. And when that branch is subsequently merged back into master, there's no footprint left. Everything gets deleted, and that code then gets pushed to production. We're not going to go into CI/CD now, but this architecture stands in dev as well. And that's it for this. Next, we're going to step into the front end. So here, this is where Lambda at Edge comes in, and I would love to talk a couple more sentences about that. So in order to serve large volumes of attendees, we decided to really create a statically served client and opting out from the server-side rendered option that Bizzabo has used in the past. I think that statically building a client, and we use S3 as an origin for the CloudFront CDN, really disconnects us from the need to be powered by compute to serve our client. And that really creates just a super fast, super scalable application. There are two Lambdas here. So token transfer. So Lambda at Edge are actually Lambda compute units that are deployed on edge nodes of CloudFront, and they offer different capabilities that Alexander talked about. They really allow us to hook into the request. So you can hook before the origin call or after the origin call or before the request, and really apply logic at any place there. And when transferring between Bizzabo domains, so we have multiple domains for keep the same token valid without using like a unified cookie. That's how when redirecting between domains, there's a backend component, the Lambda, that is able to set the new cookie for the new domain with the new refresh token and the new authorization token for the attendee, not requiring him to relog in and not requiring us to create just like a massive cookie that would hold all Bizzabo domains. And the rewrite Lambda at Edge function serves, so because the client is statically built and there's only one client, there's no compilation or build per customer. So when you browse to attendees.bizzabo.com.eventid, for instance, that static file doesn't really exist in S3. The rewrite function leverages the capabilities of Lambda at Edge to really rewrite the HTTP request, serve HTML from the client which will then be returned to the customer. From there on, the configuration will be served statically as well from CDN, and the attendee can really get the personalized event page that the organizer has created for him. All this stands before Bizzabo backend that I've showcased in the previous slide. And the amazing thing here is that when I say white label ready, so a lot of our customers require the use of their own domain on top of the Bizzabo front-end and backend, and this whole architecture enables a customer to use mycoolevent.com, proxy it by CNAME to the endpoint, and this should all work. All right, let's deep dive a little bit into video, since I've emphasized its importance so much, and how that provides us a scalable interface. So video is a crucial part in Bizzabo. There are two types of videos at Bizzabo. There's broadcast, which is what we're using now, which is where I cannot see anyone and you guys can see me. And then there's interactive, which is more like a Zoom experience, which is RTC. And it's really here a mix of first and third party components. So what we did is we created, and you can see that in the application VPC, a video management service and a media management service, which are extremely strong abstractions. And they abstract the lifecycle and the control of video, Bizzabo backend. And they proxy request and logic to either one of our broadcasting engines or one of our interactive engines. I won't go into too much detail about how each engine works, but the point is that it's loosely coupled and powered by Kubernetes. So in general, the backend, I think, using Kubernetes and AWS allowed us, as I said, to really create extremely high granularity, a lot of asynchronous and event-driven. So Kubernetes is able to scale up not only based on CPU or RAM, custom metrics to scale up based on amount of messages in the Kafka topic, for instance. So if the service just sees that there's a backlog of messages in the pipe, that service can then scale up. In the front end, a modular approach. So each of the modules the other day I showcased when I showcased the product, like the people module, the information module, and the content, each of them are able to be embedded in the customer's own website. That enables our customers to build their own websites and use Bizzabo components statically. It's statically served, it's quick. I think in general, the unified authentication and authorization enables you throughout the backend and frontend to really give roles to attendees. What are you able to do? Create really good applications. And buy versus build. So we haven't built everything ourselves. We use a mixture of cloud and third-party services. I think Bizzabo does it in a really good way. It gives a chance to engineer it, and we're not afraid to buy it. And it allows us to move really fast. Let's talk a little bit about databases. So this diagram showcases a little bit of our database architecture in more depth. Databases are crucial to the operation of any stateless application, right? And scalability is achieved, as in previous slide, in a hybrid manner. So we manage our own Elasticsearch and Cassandra clusters using the operator pattern. We find it very easy to manage our own Elasticsearch, and it provides us amazing capabilities and extremely scalable solution. On the other hand, we wouldn't dream of hosting our own MySQL, nor Redis. Those are managed. RDS is AWS's managed MySQL service, and there's a primary node, and there are multiple breed replica nodes which receive data from MySQL's bin log at a short delay, and are able to operate as a primary node in the original primary node fails. That's how that database stays resilient. On top of RDS is a crucial component called Rds Proxy, which is basically also something that was mentioned in Alexander's presentation. It's a totally managed service just serves as a connection pool manager. And the use case for this is just pretty simple. Kubernetes sometimes doesn't know how much power it has. So let's imagine a situation where you have a MySQL node that is able to maintain 100 connections. It's CPU bound, and MySQL just works like this. And you have 100 backend pods that require a connection to that same databases. It's going to be very difficult for Kubernetes to spin up 150 pods, because you're able to when you need, but those services were not going to be able to their databases and are ultimately going to fail the liveness and readiness check. What Rds Proxy does, Rds Proxy is able to handle a much larger volume of connections. All the services would connect to the Rds Proxy. It just proxies the request and it manages them. It puts them in a queue. You to really leverage Kubernetes to scale up to immense sizes and still maintain connectivity to database connection, like to database reliant database that are really heavily constrained by connections like MySQL. We also use Redis for cache, and as I said, Kafka, which is managed by Confluent as a third party. So again, buy versus build, super granular and really hybrid architecture. So just to summarize, I think Elastic, I would start with so easy. It's a lot easier than it looks. It's extremely cost effective. Elasticsearch using the operator pattern deployed on EKS can actually be provisioned by Spot instances, which are amazing. I'll touch on that in the next slide. We actually use our own internal logging solution based on such an Elastic. In terms of MySQL, so because of the way Kubernetes is architected, and because of the segregation we have between data domains, there's a host per domain. This allows for small databases that are able to grow, and each microservice has its own, which has its own read replica, and it really creates like a loosely coupled architecture. It's highly available because of the read replica. In terms of Kafka, Kafka is used internally within Bizzabo as the backend nervous system. It's also exposed using sockets to the client, and it serves as messaging and really promotes event-driven architecture, which really is the key to really scale and deal with traffic spikes. But that's a talk for another day. I think Kubernetes deserves the last slide. I really wanted to, I can talk for ages, and I'm sure you guys can as well. I really wanted to showcase how leveraging AWS EKS with Kubernetes is amazing. Because what we do here and what I wanted to showcase is really the flexibility and the cost effectiveness. So Kubernetes ultimately requires VMs to provision containers on. And what we have done at Bizzabo, so Bizzabo uses a mixture of on-demand instances and Spot instances. So Spot instances are reserved capacity or spare capacity, instances that AWS at a reduced price up to 80% cost saving. The caveat is that these instances are able to be taken away at like a 2-minute notice. So whenever AWS needs that capacity back, it sends an API call, and after 2 minutes, the instance is gone. So this would seem a little bit crazy, but it really promotes the Kubernetes use case, because Kubernetes is such a strong orchestrator that using it the right way had to Bizzabo at least to be extremely effective and amazingly hybrid. So what we do is, so each Spot instance represents a spot market that you can bid on. And what we do is we configure multiple node groups in Kubernetes to represent multiple auto-scaling groups. These auto-scaling groups by instant types in order to increase entropy and reduce the risk of losing multiple machines. We then, with affinity and anti-affinity, spread the load of the deployments across all these auto-scaling groups or nodes, Kubernetes would call it. And using that, so each one of them is auto-scalable, yes. And using that, we're able to execute our production cluster using 80% spot instances and save a lot on cloud consumption. And really not be afraid to create more, onboard more customers, provide really high quality video, really super quick like socket connectivity, and not be hampered by like increasing cloud costs. And I think with this slide, that is it. So thank you so much for enduring through this. I hope it was interesting for everyone. I enjoyed really much, and that's it.
Thanks so much, Daniel. Thank you. That was really interesting, and it feels like that you have a really mature architecture with a lot of components, and using a lot of approaches here, and even Lambda and Edge, which is very specific use case, covering very specific use cases. So I was wondering, maybe you can share what was the biggest challenge for you while building this architecture, and what was the biggest, like eye-opening experience?
That's a great question, Igor. So I think the biggest challenge was actually configuring Kubernetes in a really good way where we can create. So scalability is not only achieved through cloud, it's also achieved through our amazing engineering team able to develop using it. And I think that it took us a while to create the necessary infrastructure around Kubernetes in order to make it usable by everyone who joins Bizzabo. So we don't hire engineers that have previous Kubernetes experience per se, if you do anything, but enabling and empowering engineers to use Kubernetes when they engineer, when they test, when they create their dev environments, creating a really good CI/CD on top of it was the biggest challenge. And the eye-opener, to be honest, I think we did it in a pretty good way. So Bizzabo is full CI/CD to production. And the actual eye-opener was when the dev environment in terms of VMs and pods was like twice the size of the production environment. So we had to incorporate some logic to clean up the environments better and actually have dev reflect the actual work that's being engineered and not have it twice the size of the actual production cluster.
I see, got it. And earlier today we were talking a little bit about infrastructure as a code, and what's your approach at Bizzabo?
So we automate everything. Bizzabo uses Terraform to provision the EKS clusters themselves, as well as any supporting infrastructure that is required by the Bizzabo application to function coherently. So those are instances, Elasticache, Redis instances, DocumentDB, MongoDB instances, SQS, SNS. So all the miscellaneous infrastructure, as well as the EKS itself with the VPC, networking, NAT, peers, everything is managed by and provision form. We don't manipulate the cloud manually at all in production cluster.
I see, got it. And that was one of the questions. How big is the team considering how much automation you have?
Talking about automation of DevOps, so the DevOps team in Bizzabo is really an enabler to let engineers do the work themselves. We want to empower our engineers to be able to move their code between environments and use it and debug their applications. So there's one DevOps team, an amazing team that enables engineers to efficiently write code and add monitoring and debug their environments. We feel like this is the only way to really create highly distributed and efficient teams.
Got it. And one of the interesting questions is, how do you decide whether you want to build or support some tools, like, for example, like MySQL database or Kafka service you mentioned, or use a managed service?
It's a great question. I think hosting our own MySQL cluster is like a 1980s problem. I would never ever do that. But when it came to Kafka and Elastic back in the day, so what we did is we looked for the operator of Elastic or Kafka. An operator is a set of toolkit that is specifically written and overrides a set of Kubernetes objects and gives you additional functionality. And we know Elasticsearch at Bizzabo. We haven't had much experience with Kafka, not using it and not provisioning it back in the day when we started. So we stood at a junction, and since there was a lot of knowledge of using Elastic, we felt right and up to the challenge to try and provision it ourselves because the operator was extremely well. And on the other hand, dealing with Kafka and Zookeeper and brokers, and we didn't know how to use it and we didn't know how to provision it, so we just said, okay, this is too big for us. Maybe we'll try when we get some more experience, and we just went and did some research and purchased Kafka.
Amazing, amazing. Thank you for sharing that. And probably the last question for today is, again, you have such an interesting and big architecture with variety of components. What are the next plans? Is there any potential to optimize it further?
That's an amazing question. So I think the first thing I want to say is that to us, if anything stands out, if anything is ad hoc, it's probably wrong. We want to be bog standard, advanced, complex, not. I think what's waiting for us is more of the same, just optimized in terms of scaling. I want to see all services scale up at least once a day so that I know the thresholds. In terms of databases, I really want to understand consumption better and balance compute power versus database power. And I just want to be more event driven. So more relying on Kafka and asynchronous communication.
Got it, got it. So, all right, Daniel, thank you so much for your presentation. Thank you so much for sharing details of your infrastructure and the culture of your company. That was amazing, amazing talk.
Very much.
Thank you. And a few last words for all of you who are with us, who enjoyed this session with Alexander and Daniel. I want to let you know that next week on Tuesday, October 19th, we're going to be running AWS Technical Conference online, and please look out for follow-up email after this event with all details, or you can just search on the internet AWS Technical Conference. It's also on a website of the AWS User Group Ukraine. So thank you so much for being with us. Thank you so much for coming to this event and enjoying these conversations, asking the questions, and for being with us. Thank you. With that being said, my name is Egor, and it was a pleasure to be with you tonight. Thank you.